Hello everyone. So in this video, we will be discussing functions. So function is a relation such that no two distinct ordered pairs have the same first coordinate. So basically, in this video, we will just be discussing the operations on functions. So we have here the sum, the difference, the product, and quotient of functions. So for the sum of our function, we have this symbol f plus g of x is said to be equivalent to f of x plus g of x. And the difference is f minus g of x is just equivalent to f of x minus g of x. And for the product, the same. We have f times g of x is equivalent to f of x times g of x. And we also have that f divided by g of x is equivalent to f of x divided by g of x, in which g of x cannot be equal to 0. So from here, we have an example. If f of x is equivalent to 2x minus 8 and g of x is equivalent to 4 minus 3x, then we need to find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. So again, f plus g of x is equivalent to f of x plus g of x, right? So let's try to find this one first. So here we can find we should have f plus g of x is again equivalent to f of x plus g of x, in which we know our f of x is equivalent to 2x minus 8. So we have 2x minus 8 plus our g of x, which is equivalent to 4 minus 3x. So we have 4 minus 3x. So we now have, combining this equation or the expression, we have 2x minus 8 plus 4 minus 3x. So we have combining like terms, 2x minus 3x, that is equivalent to negative x. And negative 8 plus 4, that is equivalent to negative 4. So that is also equivalent to negative x plus 4. So this is now our result for our f plus g of x. Now let's also try to solve our f minus g of x. So we have here f minus g of x is said to be equivalent to f of x minus g of x, wherein our f of x is still the same. We have 2x minus 8 minus our g of x, which is 4 minus 3x, and that is equivalent to 2x minus 8 minus 4. Negative times negative, that is positive 3x. So we have 2x plus 3x, that's 5x. Negative 8 minus 4, that is negative 12. So this is already the result of our f minus g of x. Now let's also try to solve our f times g of x. So we have here f times, this should be f times g of x is equivalent to f of x times g of x, wherein again we have 2x minus 8 and we have 4 minus 3x. So we'll just have to multiply this by distributive property. We have 2x times 4, so that is equivalent to 8x, and 2x times 3x, negative 3x, that is negative 6x, and negative 8 times 4, that is negative 32. And we have Negative 8 times negative 3, that is positive 24x. So combining like terms, we have 8x minus, I'm sorry, this should be 2x times 3x, that should be squared, 6x squared. So arranging this one into according to the exponent of our variable, so we have negative 6x squared, 8x plus 24x, that is plus 32x, and we have minus 32. So this is now the result of our f times g of x. Now for the division of our f divided by g of x, that is just simply f divided by g of x. That's just simply putting f of x at the numerator and the g of x at the denominator. So meaning to say we have 2x minus 8 divided by 4 minus 3x. Since we cannot perform any division for this one anymore, we cannot simplify this anymore, then this is already our final answer. So that is how we operate or do the operations for the functions, the basic operation of the functions. So now we'll move on with the composition of functions. For the composition of functions, um, this is just um, this is just the combination of two functions in one expression. So let f and g be any two functions. The composition of um, f with g is the function f symbolizes by this one, defined by f with g of x is equivalent to f of g of x. So meaning to say, if you try to check this one, this is just a function of x, wherein x here is said to be equivalent to g of x. So same goes if the given is g of f, if the equation is given g of f of x, then that is equivalent to g of f of x, wherein this one, f of x, is said to be equivalent to our x. So basically, this is the composition of functions. Now let's try to solve examples for this one. We have, if f of x is equivalent to x squared, and g of x is equivalent to 4 minus 3x, then we need to find f with g and g with f. So let's try to solve f with g first, and then afterwards we'll solve g with f. So from that, we know that f with g is equivalent to f of g of x, and again, our f of x is equivalent to x squared. So meaning to say, we have the x squared here. But the x is said to be, should be substituted by the value of x because, again, this is our x, right? So meaning to say, our g of x is, will be substituted to the value of our x squared. So that is 4 minus 3x squared, since it has squared here. So expanding this, we have 16 minus 24x, 2 times 4 times 3, that is 24x, plus the squared of 3x, which is 9x squared. So transforming this into an ascending form or to the descending form, we have 9x squared minus 24x plus 16. So this is now our answer for the f of g of x, or f with g. So now for the g with f, we have, so we need to find g of f of x, in which our g is equivalent to 4 minus 3x. So meaning to say, the x here will be substituted by the value of x squared. So x again will be substituted by the value of x squared. So we have 4 minus 3 times x squared. So it's just simply equivalent to 4 minus 3x squared. So this is now the result of our g with f. Okay, so let's have another example. For the composition of function, we have here, let h of x is equivalent to 2x squared plus 5 and g of x is equivalent to 5x minus 5. We need to evaluate each of the following. So first is, we need to evaluate h plus g of negative 2. So meaning to say, again, from the operation of functions earlier, we know that h, this one, is equivalent to h of negative 2 plus g of negative 2. So meaning to say, this is our h of x. So our x here is equivalent to negative 2. So let's just write our function here. We have 2x squared plus 5. And our other function, which is 5x minus 5. So it is said that our x will be substituted by the value of negative 2. So meaning to say, we have 2 times negative 2 squared plus 5 plus our 5 times negative 2 minus 5. That is, if you try to calculate this one, this is equivalent to 13. And the other one, if you try to calculate this, this is equivalent to negative 15. So let's just erase the positive sign. So we have minus 15. So 13 minus 15, that is negative 2. So this is now the final answer for this one. Now let's try to solve number 2, which is the composition of h with g of 1. So meaning to say, we are looking for h of g of 1 from here. So since our h is equivalent to 2x squared plus 5, and our x should be um, substituted by the value 5x minus 5. So this should be our x. So we have 2 times 5x minus 5 squared plus 5. Expanding this, we have 2 times 25x squared minus 2 times 5, that is equivalent to 50x, and square of negative 5, that is positive 25, and plus 5. So we have to multiply the 2 here to the terms inside the parentheses. So we have 2 times 25, that is 50x squared. 2 times negative 50, that is minus 100x. 2 times 25, that is 50 plus 5. And we know that the x here is equivalent to 1. So meaning to say, we need to substitute all the values of our x by 1. So we have 50 times 1 squared minus 100 times 1 plus 50 plus 5. So if you try to calculate that one, that is equivalent to 5. So meaning to say, this is already our final answer. I hope This video is clear with all of you, and I hope you learned something from this video, and I'll see you on the next video.